Hello, my name is Casey Quintanilla, and I'm going to be presenting about my information analytics final project, which explores potential relationships between air quality, avocado prices, and Chipotle stock prices through data analytics and mining. So, what got me started thinking about this is in a bunch of restaurants, my favorite being the Poke restaurant in Carborough, but also Chipotle. They're always charging extra for guacamole, and I'm sure that's because the avocado prices have gone up. But what is affecting the avocado prices so much that they're affecting my pocket? So I wanted to see how I could use data to explore relationships between um, large scale features like air quality and see how they can affect avocado prices and in turn um, businesses' bottom lines and therefore my own change. So I started by preparing the data in R. Um, there are several data sets that I used. I aggregated the average carbon monoxide levels by city for the years 2015, 2016, and 2017. Um, I then joined those with weekly avocado prices for the same time period and also joined the avocado prices with closing stock prices for Chipotle Grill for the same time period. A couple issues that I ran into were that the dates were reported differently. The avocado prices were taken on the weekends, and the closing stock prices were only reported on the weekdays. So in order to join those, I had to do a bunch of manipulation in order to turn them into week numbers of the year instead of the actual date. So I'll just give you a quick glance of what my R looked like. So over here I loaded the avocado data, and you can see it has week, number, and year, and city. Then I aggregated all 3 years for the air quality data. And again, now when I finished with it, it has week, year, city, and then the average carbon monoxide level. So to combine those, I joined on week, year, and city. So now I have just the overlap of cities, and I have information on the avocado prices and the average carbon monoxide levels. Then I loaded the Chipotle stock data. Again, fixed it so that it was week, year, and then the average closing price for that week. And then um, again, some more manipulation. And then to join the avocado and the Chipotle stock prices by week and year. So now we have the stock prices and the average avocado prices. I joined all three together, but I ended up not really using that data set very much. And I wrote them all to CSV files to import into K9. So for the analysis, I used K9, and I decided to do a couple regressions. I wanted to see how the carbon monoxide levels in the cities affected the avocado prices from those cities, and then I wanted to see how avocado prices affected Chipotle stock prices. After doing those regressions, I used 2018 carbon monoxide levels to predict 2018 avocado prices. I used those predicted prices to predict the stock prices for 2018, and then finally I used the 2018 actual Chipotle stock prices so far this year to compare and see how my model did. So over here in K9, you can see what I've done. First started loading the data. I have the avocado and air quality data here, the avocado and Chipotle data here. I have all three here, but like I said, that didn't turn out to really be related to much. So just to start with some exploration, I started with all of the data. And you can see the scatter plot here are the Chipotle stock prices by week. You can see there they fluctuate but are pretty stable by year, but you can see clearly that there's one year that was much higher than the others, and also had a lot more variation. That just kind of gives us an idea of what to expect when we predict our stock prices. So in the avocado and air data, I looked at the scatter plot for those two. I included this shuffle term because only the first 2,500 rows were displayed, and I didn't want to miss out on 2017 because those were all on the bottom. So to look at that data over here, we can see there's not a ton of correlation. We might not have a very good regression model from this, but just exploration and seeing what we come up with. So I made this linear regressor here, which sees how models how the carbon monoxide levels affect the avocado prices per city. Similarly, down here, I have looked at the avocado and the Chipotle data, and in this scatter plot, this one has a little bit more of a negative relationship between the two, but it's still not very clear because there's also some positive correlation over here. So we'll see what happens in the model. So I fit those two regressions. I inputted the 2018 air quality data and input that into the predictor to come up with new predicted, these are the avocado prices predicted from the 2018 air quality data. Then I put those into the predictor for stock prices and came up with 2018 stock prices that were predicted from this model. And in order to see how those did, we have the real 2018 stock prices for Chipotle compared to the predicted stock prices. And we can look here at our scorer and see that the R squared is a negative number, which is only possible because of how K9 decided to calculate it, but I'm used to not having a negative R squared, and I think that's probably not the best sign, and especially this mean squared error is really large, and the root mean squared error as well. So I don't think that we have a very good model here, and we can probably conclude that there's not a ton of correlation between directly between carbon monoxide levels and Chipotle stock prices. I think the models would do better if we included more factors that probably play into stock prices, such as economic, how the economy is doing in the current times, and publicity for Chipotle, things like that. So maybe I guess it should have been a question of if carbon monoxide levels affect Chipotle stock more than how it does. But this was a really helpful exploration for me, and I'm glad that I could take the work a lot with this type of data and produce a model.